Hi, it's Dave Willoughby with a quick video on using SparkML techniques to train and score CICS KPIs coming from OMEGAMON. And I'll be doing this using Jupyter notebooks. An ultra quick overview. Machine learning is about using probabilistic methods versus using deterministic methods we're pretty accustomed to. Specific machine learning types shown on this slide are classification and linear regression. In this video, I'm going to be using linear regression, which is the two examples shown in the center and the right, where you're really fitting the data to some kind of formula in some n-dimensional space, depending on the number of inputs. Quickly, the use case I'm going to show, I'm using my favorite workspace in OMEGAMON, which is the CICS service level analysis workspace. And the KPIs I'm using as inputs are transaction rate, percent weight on DB2, percent weight on redispatch, and percent time using CPU. Use those four metrics to see if I can predict the average response time of CICS transactions. What I show on the bottom of the slide is the raw data coming from the TEPS when I do a save of 24 hours worth of data to a CSV file. And I looked across this data and saw a bunch of zeros that are really boring. So I focused on the non-zero columns, if you will, and that's how I chose the four input KPIs and the one output KPI. Here I am logged into the data science experience running on the IBM cloud. I have one project. Let's bring that up. This video might become tedious. I'm on a slow network. We'll have to see how it goes. Here's various notebooks. I have no models, no pipelines, and no flows defined. What I want to demo is this OMEGAMON CICS notebook. I want to quickly go to edit mode. And start stepping through this Scala code. And I'm doing this live. You get to see just how fast this code runs. So just a couple of quick commands just to make sure we're kind of in the right ballpark. And then we execute this third cell to load all the Spark libraries. You'll notice the ins and outs and execution enumeration. So I've executed 3 cells so far in this notebook. There's some markdown to add some documentation in the middle about what's going on. Let's read in that CSV file I talked about. So we'll execute this cell. We quickly got it off the internet. And let's set the file name. We're executing pretty quickly. And read that into a Spark data frame. This is the magic of Spark. It has its data frames just like Python has its pandas data frames. And this execution took a few seconds, but here it is. Let's kind of just show a little bit about what we just read in. So here's the schema. This is all that OMEGAMON CICS service level analysis workspace data that I read that CSV file from the TEPS, and it's got all these fields, the fields you saw in that slide. Just a different view. Oh, of the data itself, I'll just show a few rows. Here it is, a little hard to read. Let's count how much there is. Should be 32 rows. It's easier to see if we use this magic percent data frame command to display my DFF Spark data frame, and you'll see the original data. And I think I can scroll to the right. Lots of columns. Let me go see if I can get back up a little bit. See the headers where all this data is coming from OMEGAMON, from the TEPS. So now we're starting into the training process. We're going to select the few columns, a few KPIs I'm interested in, split the data 80-20 into 2 additional data frames. So let's get that code running, and it's going to print some of that stuff out. So a little sloppy, but there's the original data frame again. Here's the select of the KPIs that I want to work on. The top row, I think, is the training data, and the bottom table is the evaluation data, and it's just showing 6 rows of each. So just to be a little more concrete, use here's another view of that same training data, and let's count how many rows. There should be about 80% of the 32, 28. Sounds a little high. I'm used to it coming out as 23. Here's some Bernal virtualization I don't have working yet, so I'm going to skip over that. Let's do the test data frame. I've seen this come out with various splits that don't always look like 80-20. You know, my 32 should have been split about 8 and 23, but we got a split of 28 and 4. I'm not sure why that is variable, but let's keep trucking. The next 2 cells are actually going to create the linear regression model, setting the 4 inputs shown here on the first row, and the average response time is the output that I want to predict. So let's run that code and create a model. That was pretty quick. Actually, that set the conditions to create the model. The next cell will actually create the model based on the 28, I think we said, training data points. It's thinking, it's working, and it's done. So we have a model. There's the model instance number. Now let's run some Scala code to check out how good the model is. That's going to use the test results. And you can see the R value of 0.96. That sounds pretty good. Errors look pretty small. So that's it. We have a model. So now let's move to saving the model. This is going to save it to my Bluemix Watson machine learning service instance in my Bluemix account that's paired with this data science experience account. So let's load some more libraries to be able to talk to that other service. And here's my credentials. Please don't abuse them. Here we go. We've set some variables to my credentials, do some authorization. I should back and redact those credentials. So here, let's give the model a name, OMEGAMON CICS, execute that code, and save the model. Let that execute, not too slow. And let's examine the properties of the model. Get those printed out. So you see it's a SparkML model 2.0 type, and some other attributes of the model when it was created, etc. And the label is the output. Average response time is what we want to predict. So now I should have one model in my repository. Let's run some code that just reads back the name. And yep, I'm getting OMEGAMON CICS back. And while we're here, this Scala code does some quick predictions again, I think, with the test data frame there in the middle, just to see. This is not the REST API for scoring, but you'll see, a little hard to read, but these predictions of 18.8 milliseconds, 31.0 milliseconds. So that's predicting the average response time based on these 4 input values of various quantities. So let's keep going. So now we're into the phase where we're going to do the WebSphere Liberty Profile REST endpoint in the next few cells. So let's run this code of getting that all set up. It created a token. Again, don't abuse that for me. More code to do the endpoint. And let's see. Let's execute this. So there's my scoring endpoint running out in Bluemix. Forget what this code does. Oh, I think it retrieves a list of the models. And here it is. It says a count of 1. So I have one model, and if you read through this, there it's Spark 2.0. Its name should be in here somewhere. There it is. OMEGAMON CICS is the name of the model. Average response time is the label or the predicted output, etc., etc. You see some of the other KPIs in there. So now we're going to set up the deployment endpoint based on the first item in the list, I believe. I'm not sure exactly how that code works. So there's the scoring endpoint, and let's try some scoring. This code is going to get ready to score, set up all the scoring web kind of JSON stuff, and now let's actually call the REST API. Is that what this one does? Let's try it. I forget. Oh, no, it's setting up. There it is. I'm going to pass it these fields as an example to score. I'm going to score 8, 74, and 63, which is the transaction rate, percent weight on DB2, percent weight on respatch, and time using CPU. So let's send that JSON. It's going to do a post to that REST API. And swoosh, here's the score that came back, kind of in a sub-second kind of way. And here's those 4 features that we scored, and here's the scoring result. With those features, we expect an average response time of 32.85 milliseconds. So that's it, a quick run through step by step of the Scala code in a Jupyter notebook to train a linear regression model and do a quick scoring against it after setting up the rest. So we go back to my default project. Oh, it wants me to save all this good work, so let's save it. And now let's stay here for a little bit longer. Now it says notebook saved in the green text. Go back to default project. Swoosh. Let's see if I have a model. There it is, OMEGAMON CICS. If I click on it, here's the deployments, my online scoring. And if you want, this is much slower, but you can use this GUI, you know, put in your own transaction rate, percent weight on DB2, percent rate on respatch, time using CPU, and do a predict. But I'm not sure we're going to wait around for this to finish because it's creating a whole new Spark environment. So this takes like 20 seconds, 30 seconds versus what you saw before, which was sub-second response time. So that's it. Hope you enjoyed this quick demonstration.